Welcome to the Snapdragon AR2 Tech Talk. We're so excited to dive a little bit deeper into the announcement we just made on stage. So as a reminder, if you guys have questions during the presentation, go ahead and scan the QR codes that are around the room, and at the end, we'll open it up for Q&A. So with that, I'm going to turn it over to my friend, Bakadir, to kick things off.
Aloha and welcome everyone. So excited to be here with all of you today. Less than an hour ago, we introduced our new Snapdragon AR2 platform. First of a kind. First platform purposely built to advance the state of art of AR glasses. In this session, we're going to have fun. Well, I will take you to the insides of the AR2 platforms. We're going to take a little tour around there. And then we're going to give you a quick update on some exciting engagements we've been having on Snapdragon Spaces. But just before I get started, I have a basic question to all of you. Can you show your hand if you used an XR device in the last few months? Wow. That's great. You know, I was worried because let me tell you, a few years ago, you would ask the same question. You would get one shy hand at the end of the room, if anyone at all. A few years ago, we were still trying to convince the market that XR has the potential to drive the next big transformation in our lives. That was a dream. But this is not a dream anymore. Spatial compute, metaverse, whatever the name, whatever the definition you have for it, is a reality. With VR, MR, AR, standalone devices, and smart glasses, but all converging to that perfect AR glasses that will be augmenting the world around us. And that makes us superhumans, super intelligent, more social, and more efficient in the work that we do every day. But we know also that making AR glasses is so complex. In fact, for a perfect augmented reality experience, blending digital and real items requires our brains to perceive both exactly the same way. Take this example here. Well, we'll bring in a digital cup. Look how real it looks. How perfectly it is anchored to the table with realistic shadows. And now, you want to pick it up with your hand, move it around, just like we would do with a real item. For such experience to happen, there are so many things that need to come together. A lot of perception, high-density pixel displays, a ton of processing power, and more. And that is where really things become difficult and open up the gate into a lot of challenges. But let me add to you, you want to run all of those processing in a small form factor glasses, a very stylish, sleek device that we identify ourselves with, that is part of our personality. And that's really opening up all kinds of challenges, be it thermal, power, displays, color quality, and so on and so forth, making the task that we have in hand almost in the realm of the impossible. But at Qualcomm, we can't help it. You know that already. We make the impossible possible. Technology is part of our veins, and we have the ability to bring the industry together and solve each of those challenges. And this is why we say augmented reality is a Qualcomm-sized challenge. Also, we have defined key metrics to make sure that we evaluate every solution that we bring in. And those metrics are performance, power, and size. Of course, for a successful experience, you need the optimal performance running at the optimal power budget and fitting in an optimal sized device. Unfortunately, these three indicators compete against each other. You fix one, you break the other. And we are in a journey to finding the sweet spot across all of them. And a critical step in that is leveraging distributed processing. In fact, we have been in Qualcomm championing distributed processing as part of the transformation or the wireless edge transformation. As our homes, our cars, our offices are getting smarter, we are evolving into a world where we will be surrounded by a lot of connected devices, presenting all kinds of capabilities. And why not? AR glasses can take advantage of all of that, just like getting the heart rate from my smartwatch, or getting the map from my router at home, or offloading processing to my phone or laptop, or the set-top box sitting in my living room. And that's something we have been already starting with for a few years. In fact, the first generation that we had for AR enabled distributed processing between a glass and the host over the wire. And we know nobody likes wires. But it was essential to validating the architecture and seed first-level experiences. But then we cut the cable, and we made it a wireless distributed processing. And in both cases, we have a second level of distributed processing, which is from the local host to the cloud or edge of the cloud. And this is an area that is evolving rapidly as the 5G is getting deployed and the network topology is getting optimized for XR use cases. But today, we are taking this to the next level with trying to get to the smaller form factor. And that introduced a new level of distributed processing, which is on glass. We'll talk more about that later on. But as we look into the future, and starting from here, we will get smaller and smaller form factors. Distributed processing is going to get sophisticated. And imagine a world where our AR glasses dynamically discovers devices across, and then dynamically decide what workload to assign to what device. And this is what we call the wireless dynamic distributed processing. So this is why AR2 as a first Snapdragon purposely built for augmented reality, with distributed processing really at the heart of it, is a key milestone. It is a turning point in history of our journey towards the perfect AR glasses everybody is waiting for. So in the next section, let's look into how AR2 is enabling distributed processing and how it's going to be making an impact on the key areas we identified of size, power, and performance. Starting with distributed processing, and mainly the local distributed processing. We all still going to have our smartphones with us. And as we just announced, our first Snapdragon 8 Gen 2 today, we will be enabling AR2 with distributed processing with Snapdragon 8 Gen 2 powered host as a first configuration. Now, let's understand how all of this works. So when basically look into the conundrum that we have of power, size, and performance, really what we want to do is do the minimum possible on glasses and offload the rest into the host. And what does this mean is, let's do the minimum perception on glass, send the information into the host will do the rendering of the application, send us the frame, and let's drive the display as quick as possible. What does this mean is we need three main things on the glass. One is on-glass perception, two, drive the display pipeline, and three is connectivity. So going to the on-glass perception, you have really two types of perception there. There is a perception that we don't have a choice. It's just part of the architecture, such as doing head tracking as part of the glass itself, because we do need that last pose to adjust our frames before we display them. And there is a second type of the perception, which is simply perception we cannot afford to do somewhere else because of latency, security, privacy, or any other considerations. Example of that is hand tracking or eye tracking. So then the second one is driving the display pipeline. What we want is, as soon as you get those frames over Wi-Fi, you want to decode them, adjust them, and drive the display as quick as possible, as low power as possible. And the third one is, for connectivity, we need ultra-fast, low-latency connectivity to be able to exchange data between the glass and the host side. Now, let's look into how AR2 is enabling all of that. And that brings us into the third level of distributed processing, which is basically on-glass distributed processing. In fact, AR2 comprises of 3 chips distributed across the frame. So you have an AR processor on one arm, you have a coprocessor on the nose bridge, and you have connectivity on the other arm. Now, let's dig a little bit to the insides of it, starting with the AR processor. So the AR processor is designed to fit in AR glasses and completely on top of the advanced technology of 4 nanometer, which is very power efficient. It is designed on top of a one technology roadmap, customized and optimized for the on-glass perception and the display pipeline we talked about earlier. Without spending any more time, let's get into the perception. So on the perception, we have the first item, which is the Qualcomm Spectra ISP. And this is a key core in the platform, which is customized for 2 things. One, we need to take and capture amazing pictures and videos, just similar to what we can do with our premium smartphones based on Snapdragon. Because it wouldn't make sense that I have my glasses and I have to pull my phone out to take a picture. This just would be silly. And the second thing is, this is the window to the perception. We are able to support efficiently multiple perception cameras concurrently for things like hand tracking, head tracking, or environment understanding. Next to our Qualcomm Spectra ISP, we have the EVA, or Engine for Visual Analytics. And this is a hardware implementation for a lot of functions that require heavy computer vision processing. And to explain to you the importance of this core, let's take example of 6DoF head tracking, where you see a huge jump in terms of performance versus power. So you have on the right, it's 6DoF running with EVA, and on the left, it's 6DoF running on the DSP. And the little circles that you see are the usable features that we use for head tracking. And visually, you can see that we are able to track way more features using EVA implementation versus the host, which means it's going to be more accurate and more robust. And not only that, look at the chart at the bottom. We are able to do that with a fraction of memory footprint and a fraction of power. And this is a problem you will see even more as we go outdoor, where we are a lot more challenged with the natural lighting we have in the environment. So next in line is our Hexagon DSP. And I'm sure you heard a lot about the power of our Hexagon DSP through the summit so far. But nowhere it is more important than for AR. This is for evolving workloads that require vector or AI processing that we need on glass and not on the host, not somewhere else. And we'll take an example here again of hand tracking. So when you look at this here, this example, you will see 3 hands. There is the real one, the red one, and the blue one. So with the red one, it's processed on glass. And with the blue one, it's processed on the host. And you can see the lagging as you move in your hand, which will kill, by the way, your experience. So this is on the part of the perception. Now let's look into our innovation we added on the display pipeline side. So remember, what we want to do is as soon as we get the frames, we want to be driving the photons on the display as quick as possible and as lower power as possible. So as soon as we get the frames over Wi-Fi, we feed them into our Qualcomm Adreno video processing unit, which is customized for low power and for low latency that we require for AR. Once frames are decoded, we feed them into our Qualcomm reprojection engine. And this is one of our latest innovations. This is a hardware implementation of a function that will stabilize the content based on the latest user head motion. And this is a critical for really any immersive. This is how you would get sickness if you would not have this done properly. And this is important to do at low power because traditionally we would do this on big cores like GPUs. And here doing it in hardware enables us to do it on much lower power. Once stabilized, we push the frames then into our Qualcomm Adreno display, which is completely designed and customized for AR displays that are different than other displays that you have today, like in smartphone, because they require much higher frame rate. And we support things like field sequential display, which will save a lot of latency, a lot of power, and a lot of money if done externally. It's either do it on the chip or do it externally. But we do it in chip, you save that from the outside of the chip. So these are some of the key cores we have in the AR processor, and there are more. But just because of time, let's switch into the AR coprocessor. And before we dive into the inside of the AR coprocessor, I heard the question, why even do we need it? What problem are we trying to solve with it? So let's go without an AR coprocessor. Look to a solution with a single chip. And remember, we said we're going to have a lot of cameras, you have displays, you have Wi-Fi, all kinds of components. And all of those need to be routed back to that single solution. Look how many lines. There's so many lines that the design is going to get complicated. People that are designing glasses know this. Your design is going to be way more complicated just having to route all these lanes. And that's why you see a lot of them bulky. A lot of them even, they don't have the hinge. You cannot even have a hinge. And with AR coprocessor offering a sensor and camera aggregation, we are able to reduce the number of lanes that you have to route across the frame. But not only that, we are adding an AI and a CV acceleration there for things like eye tracking, object detection, or just biometric authentication. These functions actually help on one key thing, which is distributing the thermal. I could do everything in the AR processor, but if I distribute it, it allows me to distribute the heat across all the frame. And finally, it's the Wi-Fi. And for Wi-Fi, there are really three key things we need to remember. We need sustainable high bandwidth. We need sustainable low latency, and we need all of that in lower power. And there is nowhere this is better in our latest Wi-Fi 7 chip, Fast Connect 7800, which is offering less than 2 milliseconds in sustained latency, up to 5.8 gigabit per second in bandwidth, thanks to the high-band simultaneous multi-link, which is the only chip that supports this today in the market. And we are able to do this at 40% lower power. So this basically makes our AR2 platform with on-glass processing and with the local distributed processing. Now, let's look into how is that making better our key metrics. And let's start by size. Again, compared to a single chip solution, we are able to, with the solution that we have, we are able to get 40% smaller PCBAs and reduce the number of wires we talked about by 45%. And if that's not enough, we are able also to make our frame smaller. Look at the chip size. We have a 10 millimeter on the temple. It's intentional, just to make the temple smaller. And also, our coprocessor is about 6x4 to fit in the nose bridge. Next, on power. all the talk about low power. How much are we able to get there? We are able to get 50% less in power. This is huge, ladies and gentlemen. It's not small. Next is performance. And on performance, we can talk about a lot of parameters. We shown the 6 DOF, like in terms of accuracy and robustness. We showed hand tracking with low latency. But we're going to focus on 2 more. One is AI, and we are able to get 2.5 times better performance compared to previous generation for things like image recognition or hand tracking or classification. Another key metric is motion to photon. I talked about it earlier. For really, really great experience with immersiveness, you need a very acceptable motion to photon. And with AR2, we are able to get to 9 millisecond motion to photon. And this is a huge milestone again. So this is AR2 and what it can offer based on our distributed processing. And that's why we mentioned earlier, this is a key milestone. It's a turning point in the history towards the perfect AR glasses. And we're not done yet. With this platform, we will be offering a lot of software. And we'll be offering a development platform that will enable our partners to go to market much faster. And speaking of the partners, we have a lot of them already lined up and engaged with us, exercising with AR2 platform, and we have a lot more. This is just a taste of the engagement that we're having. AR2 is really I would say it's the latest addition to our ever-evolving roadmap of XR. And it's very special in its kind. It creates its own line of product as it's designed solely around the distributed processing. Our line for XR will continue in parallel, which is dedicated for VR, MR, or ER, standalone, or in any other form factors. And we will be expanding, just like what we've done for VR, into a high tier, a high quality tier, to be able to address the entire market. And look up for exciting news in the future on what we're going to do there for AR. Now, let's bring it all together. We talked about how much AR is a complex task and how distributed processing is at the heart of the solution, and how AR2 enabling distributed processing and striking that balance between power, size, and performance. We are able to get 40% smaller designs, 50% less power, and our performance are unprecedented, with 9 milliseconds in motion to photon, 2.5 times in AI that you can run on the glass. We provided all the tools with the AR2 development platform to enable our partners. And we're not done yet. Now, how do we make that available to our developers, to our partners, to start really building exciting experiences? And this is where Snapdragon Spaces comes to picture. And there is nobody better than my friend to talk about that. I would welcome Lukas to come and talk about it.
Well, fam, we've made it to the future. I'm here standing on a 360 stage for an XR Tech Talk. I'm looking around. It's a joy to be here, surrounded by all of you on your giant marshmallows. And I'm putting myself in your sandals, thinking, we just sat through a Qualcomm-sized information overview on the XR hardware. And while you're there processing all this data, Saeed says, I'm going to come up and talk to you about Snapdragon Spaces. And I'd say you've got 3 things at the top of your mind: who, what, and Hawaii. And honestly, same. So we'll try to keep this tight and get a little fun in there. I'm a product manager in Qualcomm's XR software team. We provide software to support our XR hardware. For what is hardware without software? untapped potential. And what we do is we help those great hardware platforms thrive with app experiences. And who delivers those app experiences? Developers, developers, developers. Yes. We're going to tap into a little bit of our history, as Qualcomm has a track record of proven technology and innovation in building XR software, along with decades of brewing mobile app ecosystems. And when you put those two things together, you get Snapdragon Spaces. That's the wrong button. You get Snapdragon Spaces, our XR developer platform. It's an SDK that developers can target and core software that OEMs can integrate with. What this does is it widens both funnels, allowing OEMs have access to broader ecosystems and developers to have access to wider distribution channels. So we launched earlier this year with an augmented reality form factor. It was mobile connected augmented reality glasses because AR glasses, AR is one of the hardest, most complex problems to solve. I mean, look at this slide. Now back at me. You used human perception to perform that exercise. And by scanning the room and perceiving human body detection or images, then AR glasses, AR devices have to do the same thing. Now back at the slide. Look at these. Positional tracking, object recognition, plane detection, hand tracking. Every single one of these features runs through a constantly computing high-performance algorithm that's perceiving the world not just every second, but up to 30 to 60 frames per second. That's a lot of demand. Fortunately, we know hardware. We know software. So what we can do is tailor these software algorithms to our chip and deliver those algorithms and software to OEMs and developers. And we got to make it accessible. And the way we do that is we support and extend OpenXR, because Snapdragon Spaces was built as an open platform from day one, including integrations with the leading game engines, with plugins available for Unreal Engine and Unity right from the jump. This makes it easier for developers to use the software that they already know and they already use to port apps easily in and out of our platform. The response has been tremendous. We have thousands of developers engaged on the platform, with over 50 early access and Pathfinder participants. And what these developers do is that they help us create a tight feedback loop so that we can make sure that we offer the right features and enhancements as we build and grow this ecosystem together. Now, where we started with AR, what we've done is take Spaces and expand it into compatibility with VR and MR. MR, also known as mixed reality, or pass-through AR inside a VR headset, has been gaining a lot of excitement and traction lately. And with this new demand, then app developers can take the experiences that they're already building with Spaces for AR and easily port them into MR. What our engineers are doing is making sure that these experiences are as identical as possible between augmented reality and mixed reality. And you can see some of those tests here. And what that means is that developers can take a Spaces AR dev kit today and already start building for mixed reality devices tomorrow. And once they have those mixed reality devices, they can use those as dev kits to build for our future platforms that are powered by AR2. So we know that hardware update cycles can be long. So what we've done is we've packaged these perception algorithms and our OpenXR runtime into a downloadable APK. This way, we can deliver new features and enhancements over the air directly to Android devices that are Spaces capable. Or, as we like to call it, Snapdragon Spaces ready. What we're doing is working with OEMs to bake in the unique requirements for high-end XR so that they can be Snapdragon Spaces ready. And the newly announced Snapdragon 8 Gen 2 mobile platform will be supporting Spaces ready from a hardware level at launch. This here is a number of growing list of OEMs that are committed to supporting these Spaces devices at launch. Now, one of the best parts about what we're doing here, the most rewarding things, is watching what developers are building with our software. And we'd like to highlight a couple for you today. First up is Trip. Now, Trip was the first app developer to truly prove out what Spaces can do by taking their pre-existing built XR app and move it over to Spaces in just a few days. And by doing that, it freed them up so that they could start playing with other features as we're an Android-connected ecosystem. And so we're going to watch what they did here.
Trip is a new way to meditate using XR technology. We're excited about expanding our experiences into augmented reality and working with Qualcomm using the Snapdragon Spaces platform. Our goal at Trip has always been to incorporate biometric data and create adaptive experiences that can respond to that signal. We took the heart rate variability data coming from the Snapdragon wearable, and we adapted the augmented reality experience in real time based on your heart rate variability. We take color and the speed of motion in the experience as you're moving through this little game that's designed to focus your attention. And when you're in a state of focus, it slows down to give you real-time feedback that you're in that zone. And when you're experiencing some stress in the experience, it speeds up to reflect that back to you. So it's telling you, as the user, how to self-regulate. At Trip, we are excited about this concept of reality layering and using XR technology to transform the way you see the world around you. And Snapdragon Spaces is the best platform to facilitate that for us at Trip.
Relax, there's more. Where Trip used biometrics to access our rhythm, our next partner, Trigger, took a different approach: music. Music can take us from an otherwise ordinary world and make us come undone, almost like a reflex. So Trigger partnered with a band notorious for their work with music and technology, Duran Duran. And fortunately for us, we caught these boys on film.
From the very beginning, when we formed Duran Duran, technology was important to us. We weren't the kind of band that just put on jeans and a t-shirt and went and played our songs. It was all about the overview. What could we do together as a creative unit? We've always tried as a band to use our music to change people's worlds, to transform their audio space into a new reality. We're always still searching for that wonderful opportunity to do something new with technology. And so Qualcomm came along with Trigger designing an augmented reality. And it just seemed like a great combination. If you put on these rather beautifully designed glasses, it's Duran Duran's music in a different universe. It's a different dimension. You can touch the music, you can change the music, hear the music in different formats, and hopefully you'll have some fun too. Snapdragon Spaces is the platform that made all of this happen.
Snapdragon Spaces provides an open platform for developers to create immersive experiences using the latest perception technologies on emerging XR devices. We're excited to be working with innovative creators like Duran Duran and Trigger to reimagine reality.
This kind of technology enables you to take things to a completely different level. It's immersive, it's interactive, and it feels very new. This has been a really exciting process working with Snapdragon Spaces to bring this augmented reality to become a reality in our world. It's a whole different level, it's a different experience, and it's only the beginning of what we're hoping to do. I think this augmented reality project is really the first of its kind, and I'm so excited to see how much further we can push it. This is Duran Duran Reality Reimagined, so come and join us.
We hope you're able to try some of these experiences this week. And these are just a couple of the experiences that we want to bring to the forefront. Snapdragon Spaces requires the most world-class software available in order for our developers to build the best experiences. And it's a bit short-sighted for us to think that we should build all of these things ourselves. No. More like a good heist movie, it's time to bring in some help from a few friends. So first up, spatial UX. This is a very hard problem to solve in headworn. Think about the last two experiences that you've done, and think about how different it was to interface with that UI. What we need are standards. And fortunately, there is a company that stands above the rest when it comes to cross-platform XR interactions. And that company is Microsoft, with their multi-platform mixed reality toolkit. What we're announcing today is a close collaboration to bring MRTK3 compatibility to Snapdragon Spaces. And here with me today to talk more about that is Microsoft's own product manager for MRTK, Grace Hsu.
Hello, everyone. Thank you for coming. At Microsoft Mixed Reality, developers are our heart and soul. They're the ones who created the rich XR experiences you see today. But more importantly, they're the ones who will define what XR is in the future. And what we on the Mixed Reality Toolkit team want to do is to help them unlock the full potential of what the future holds. MRTK is a cross-platform toolkit that provides spatial UI and interactions for mixed reality app development. And today, I'm super excited to announce that in addition to all the devices and platforms we currently support, HoloLens, Quest, Steam VR, and others, we have another, Snapdragon Spaces. And here I have a video our teams put together of our newest version, MRTK3 in action on the Snapdragon glasses. So let's take a look. So this is Flappy. We decided on a tropical bird as we're here on the beautiful island of Maui. And how this works is it uses MRTK3's hand tracking, UI, and world and body locked holograms so that when you put your hand out, Flappy will come and perch on your finger, like so. It's pretty cute to experience. And because it's built on MRTK3, it's cross-platform and will run on any OpenXR supported device, which is so powerful because now you only have to build your app once and then you can deploy it everywhere. So this is a small demo app that we put together to show the power of MRTK3. It's pretty amazing what you can build in just a few hours. As you just saw, the future of cross-platform XR is here. And MRTK3 is the enabler. Now the fun doesn't stop here. We have an exciting event coming up in February for our launch of MRTK3's general availability, where we'll go over all the newest features in MRTK. So stay tuned to our social channels and come build the future of XR with us. Thank you. And now back to Steve.
Thank you, Grace. Now, it has been a really fun journey working with the entire mixed reality team over at Microsoft. And I do have to give 2 shout-outs to Finn Sinclair and Curtis Evelet, whose unique engineering skills really made this possible. Okay, perception, UX, where else should we go? Well, how about calling back to another real-world collaboration that we've just announced with Niantic and their Lightship platform. Here to help us navigate this relationship is Niantic's own head of product and strategy for AR headsets, Skji Conklin.
Thanks, Steve. So at Niantic, we asked the question, what if technology could help improve our lives? What if it could help us get up off the couch, exploring the world around us, reconnecting with friends in real life, and maybe even making new ones? This new generation of outdoor-capable consumer AR glasses are going to help us get outside, break free from looking at the world through the small window of our mobile phone screens, and keep our heads up and engaged in the world. The possibilities of what people will do with this technology are endless. At Niantic, we're building the 3D map of the world to power what we call the real-world metaverse. Now, the power of VPS enables developers to anchor their digital experiences to real-world locations. So finally, bits can realistically and believably appear to interact with atoms. This is the foundation of the real-world metaverse. Our map has coverage in over 125,000 locations around the world. And that coverage is growing and refreshed rapidly by our community of surveyors, developers, and players. Developers leverage the power of VPS to anchor their AR experiences to real-world locations and persist them. And when users appear at those locations, we localize that user in space and render the AR content in front of them with centimeter-level precision. And we're embracing open standards and cross-platform tooling. So it's going to be easier than ever for developers to create engaging AR experiences that shine across platforms. With the power of VPS, developers can now make any place, anything more useful, more magical, more fun, more alive. And when those experiences leverage the power of realistic physics and occlusion, these experiences are going to feel more real than ever. Imagine your favorite character scurrying and running behind a real tree. Imagine playing with a digital ball that feels real because of how it's interacting with you and your environment feels really natural. These experiences are going to get you to explore, exercise, and socialize. And as I tell you a little bit more about the types of experiences you're going to see a closer look at the content Niantic has already built for this class of devices. So first, you're going to explore. You're going to have fun reconnecting with those familiar places, discovering new ones. Imagine experiences like taking your digital pet for a stroll around your neighborhood, or going on a superhero mission with friends around your city. And how you interact with the world matters too. For some of these experiences, hand tracking is perfect. And for others, you'll want to carry a small, lightweight controller in your hand. Next, you're going to exercise. You're going to be outside playing. Some of these experiences are even going to be designed to make you sweat, whereas others, a simple stroll will do. And finally, you're going to be outside playing with friends. There's something truly special and magical when a group of people get together and they see the same AR creation rendered in the exact same location, and that creation is interacting really contextually and naturally with you, your friends, the world around you. It's a really special, magical experience that's shared together. And we invite developers to join us, creating content designed for this new class of devices. And we are so excited to be continuing on this journey with Qualcomm, bringing this new generation of outdoor-capable consumer AR headsets to market. Thank you, and see you out there playing. Thanks, Steve.
Oh, that is so awesome, Skji. I cannot wait to play those experiences, and I also can't wait to see an AR Pokédex. And what that is, think of it as a collection of Pokemon that have agreed to work with you. Oh, kind of like this. Well, the Snapdragon Spaces, it acts as our XR glue, our hub, to allow us to work with partners up, down, and across the entire stack to target all of the XR head-worn form factors. We look at things like open standards, collaboration, shared ideas with top partners in the space. It becomes more and more clear with every growing collaboration that XR is a team sport. And collectively, we came to play. Snapdragon Spaces will be evolving further in 2023. Watch out for that. And now, thank you all for coming. I'm going to bring back up my friend, colleague, and mentor, Saeed Bakadir.
Stay with me. So thank you so much, Steve, and thank you guys. As you can see, this is a turning point in our history. You can see that the effort with AR2 platform and how it's going to change the world towards the holy grail device that everybody is waiting for. And paired with Snapdragon Spaces and having partners like Niantic and Microsoft, having you guys and having all the partners around, we are sure we're going to get there. But just remember, we are in a journey, and nobody is allowed to drop their hands until we get there. Can you guys promise? Come on, can you guys promise? Thank you, thank you. Now, I would like to ask Skji and Grace to come back. I would like to ask our GM, Hugo, to come over, and we are happy to take any questions you guys would have.
All right.
Great. Like we've discussed at the beginning, we should be flashing up a QR code to take some questions, so feel free to submit those. In the meantime, I will remind everybody that tonight at Maui Brewing Company, we'll have all of our XR demos. So please check those out. And another hot question is Duran Duran playing at the Luau? The response is no, unfortunately. Maybe next year. So we will wait for questions. I'm not sure if anybody on stage would like to build upon anything.
Oh, I think hopefully you realize all the things that we put together, right, from the platform side, working together with the smartphone, and then on the ecosystem side with the Snapdragon Spaces, our amazing partners, and this is the beginning of our journey for augmented reality. You all know that we got pretty good traction with virtual reality, right, empowering most of the devices out there, and now it's time for AR. So happy to answer any questions.
We got one. So the question is specific around Niantic. Are we really just focused on the hardware side? We brought up Spaces, but is it solely reference design and hardware based, or more broad in scope?
Yeah.
In terms, is there any more information in terms of what they mean?
Oh, I would answer as three pillars of our collaboration. The first one is on Snapdragon Spaces, right? So Niantic and Qualcomm, we came together and say, it doesn't make sense for us to build two separate ecosystems. Let's build one, right? And we have the Spaces APIs that I think Steve talked about. But what about the outdoor mapping? You know, that's a key strength from Niantic. And then we're just plugging these things together. So a Spaces developer, you want to use an outdoor mapping, hey, there's an API from Niantic Lightship platform. So that's number one. And then number two is, I think the question where it was addressed is on the device, the hardware. And Niantic has been working for the last at least 2-3 years on optimizing that design for outdoors, right? That's kind of what Niantic really is driving towards. And then working with us, you know, we want to build that hardware, we want to build that as a reference design to enable others to commercialize together. And then third is on the content side, right? First-party products that can be optimized on what we're building together. Would you agree to that, or?
Yeah, absolutely. I think you covered it all. I think in general, just thinking about getting behind open standards together, right? What are the areas that we can put our weight behind, and also go to other partners, work with everybody to really just get behind standards in that, so that it's really easy for developers to be able to just build once and deploy across many devices, and really have, you know, all those technologies collaborating and powering those experiences together.
Yeah, maybe, you know, something that is off what we discussed, but yeah, I think we both Niantic and Qualcomm, we have a very much a shared vision on how we want to develop, you know, spatial compute, right? Yes, there are vertical systems being built, but we believe in a solution that can scale, right? That you enable new players, new partners to come and have a value in the metaverse, in the spatial compute ecosystem. And that's, I think, very much speak to what Mariam just talked about, on working together on standards, on enabling this to as many people, be it on the hardware or on the software side.
Question there.
Yeah, we're going to go off Slido. Okay. So how far away are we from having a standalone device that doesn't rely on a processing puck or smartphone or distributed processing?
I mean, that is, of course, the holy grail, right? You just want to have a glass and not need anything else, right? I don't need any more screens. All I have is a glass. Now, I think, you know, in the keynote, Deb talked about some of the challenges. And I think for the next few years, it's still going to be a trade-off between size, comfort, you know, how immersive you want to make these glasses. And I think that's what we came to the conclusion, that to put this together, having a small form factor glass and still be an immersive experience, we had to split the compute. And this is a great solution, because everyone has a smartphone on their pockets. Everyone has a PC. And we see this distributed compute evolve over the next few years. And by the way, even when you think about a standalone AR glass, well, to be honest, it's not going to be really standalone, because what we see is the split compute will be between the glass and the edge of the cloud. So it's just that, I think if I understand the question is, well, I don't need any other device in proximity. But that's how things are going to evolve. You know, I keep, I think in a few of the roundtables today and individual one-on-ones, I kept kind of making the comparison to the mobile internet evolution, right, with the smartphone evolution, where things don't happen, you know, overnight. It's a journey where every year you get improvements in the processor, in connectivity, in ecosystem. And over the course of 2, 3, 5 years, you get something amazing. And so I think that just, you know, short version of what I just said is that for the next few years, this is going to be the architecture, is distributed compute, so that we can put together the benefits of a small form factor device with the immersiveness that we all want.
What are the thermals and heat and battery life of a Snapdragon AR2 glass? Because this person wants to catch multiple Pokemon in one run.
Well, it's not an easy answer. It is a somewhat bounded problem if I talk about power, which we said, under 1 watt. Now, the question on thermals, well, it's, how do you distribute that 1 watt within the glass and then have, the thermal mitigation, thermal dissipation technologies that are also evolving to accommodate, the small form factor. And now the question on battery consumption, well, you have the power, so now, it depends on how much battery you put on the device. So, and there's a lot of innovation happening, multiple OEMs experimenting with different places and ways to accommodate batteries on these glasses. But that's something, that each OEM, each hardware manufacturer has a way to differentiate, way to create new form factors. And that's what we at Qualcomm are good at, which is to enabling everyone access to the technology, and they can differentiate, they can create their own styles and battery capacity and so forth.
Great. There's a long queue of questions, and we really appreciate this, but we're a little bit over time, so we're going to stop Q&A now. Everybody will be at Maui Brew & Co., so we're going to give folks a 5-minute break, and then we'll start with compute. So thank you so much.
Thanks, everyone.
On show.